as we deal with data structures, we're often going to be asked to draw various things. We might be asking to draw a plan for the data structure we're going to get. We might be asked to draw an instance of a data structure we're going to get. And we can often just sketch in whatever format we want to. But I think it's important to learn a little bit about some of the formal mechanisms. So you may or may not have had any experience with what's called UML, the Unified Modeling Language. And I'm not going to teach a UML from the standpoint of a super intensive training, but it is going to be important for you to start to really get a feel for some sketching technique. And I think UML is amongst the best. So why is UML valuable? Well, by learning any language, any notation, it gives you shortcuts. It gives you kind of a shorthand to look at this. So, I mean, here's a picture of hieroglyphics. Um, the hieroglyphics have some meaning. They have some semblance of passing along knowledge. And a written language like this seems pretty inefficient at first. I could just have a conversation, but it allows me to pass along information when I'm not there. And when I use a structured language like this, as opposed to just ad hoc drawings, even if it looks like it's incomprehensible now, it really has some deeper meaning, some semantics, some grammaticalness to it that is important. And so UML is that for a certain type of programming, object-oriented programming specifically. And I believe that drawing in that makes you look a little bit more professional. And it certainly improves the quality of the communications that happens. So some of you might be told or hear at some point, like, nobody really does UML. And that might be true in some instances. But I've found that it's a really big differentiating factor in my career, where when I work with teams that know UML well, we communicate quickly and more clearly because there's a meaning to it. And so really our focus right here is just two small parts of it, class diagrams and object diagrams, and really only a small slice of those. So we'll learn about them, we'll play with them a little bit. You're not going to be asked to produce them at any large scale, but you will be probably, it's your advantage to be able to produce them from time to time, and certainly read them is going to be important because I will present a lot of stuff in UML structure. So the first thing about object-oriented stuff is classes, and classes are boxes. And as we can see here, there's two boxes already. The basic box right here, the shopping cart, that is a class. You might not recognize it, but that is a class. It's a class that has no information about it. I just know there's some class out there called shopping cart. But then what I can do is I can start adding in little compartments, is what they're called, into the boxes. So there's another class that tells me it has an attribute of the last time the shopping cart was updated. Or I can add in a third compartment here, which is the methods for the class, in this case, checking out. So the name there, again, it's worth repeating, is a compartment inside of the class, each of these little boxes. And so the three compartments that are out there is the name, the attributes, and the methods. The methods being the behaviors that are happening, the attributes being the data that class is storing, that refines the class in some way. And there's actually occasionally a fourth compartment that can show up events. It's not common and is it's an older UML spec that added it. So it's usually three compartments. There could be a fourth out there if you ever see that someday. It'd be something like button clicked or, an alarm happened or user timed out or something like that would show up that class would respond to. All right, so when you have classes, typically one class is enough. I have multiple classes, so there's relationships between classes that I can draw as well. So the relationships are always between two classes, though the two classes might be the class and itself. As a student, you might keep track of other students who are your teammates, your partner, the person you're grading. There might be another thing you keep track of. So the relationships don't always have to be between different classes. They can be one object of a class to another. As a worker, I work with other people and I keep track of other workers. Or as a tool, maybe it keeps track of other tools. It works with a hammer and a crowbar work together. So all types of objects can have relationships with other things of that object. So the basic relationship is the association. That's just one thing keeps track of another thing. That's all it really implies. And there's typically numbers that are associated with that. If there's no numbers, it's assumed to be one. But I can have one of a thing or many of a thing, which is some unknown number that's more than one. Or I can say two of a thing, or 2.5 if you can store between 2 and 5 things. So again, I can have gloves, and I have 0.2 gloves. I can have no gloves, I can have one glove, or I can have two gloves. I don't normally have four gloves because I normally have two hands. I guess I could put them on my feet, but there's an example of how I can demonstrate a relationship in UML. And that relationship talks about the rules you're going to put into code. When I see 0.2, I'm saying to other people that you can only have 0, 1, or 2 of these. You can't have 3, you can't have 5. If I say 1.2, I'm saying you have to have 1 or 2. You can't have 0 of them. Another slightly stronger relationship is called composition. That's basically saying that the one class doesn't make sense without the other. So, for instance, your body needs a heart, a liver, a lungs, a brain in order to function and exist. Without a heart, a liver, a lung, a brain, you probably would die. You would not be useful. You would not be purposeful. Now, I know that there's fake ones and there's all sorts of break down to that analogy at some level, but that's the notion behind that. Is in order to be useful, you need to have one of those. We'll see an example of that here in a second. We won't go into these relationships very much, but if you do have inheritance involved, you're going to have an extends relationship. That's one class inherits from another. Or if I have interfaces involved, one class might implement another. Again, we're not going to talk about them much, but they are important relationships you might see in a class diagram at different points. So here's an example of a class diagram in action. We have a customer. It has two attributes, name and birthday, and it does one thing with the customer. You can log in with the username and password. It implies there's some sort of connection to username and password. A class does not necessarily show all of its cards, if you will. A class can have attributes that don't get showed up. It can have that don't show up. It can have relationships that don't show up. It can have methods that don't show up. Remember, a design is just one picture of a thing. If you showed me a picture of your house, it doesn't mean you have to show me every closet, every crawl space, every attic space, every drawer, every nook and cranny. You get to choose what picture you're going to present to me. And it doesn't imply that because you show me a picture that I know everything about it. Same thing is true in design. But the customer might have many payment methods that is involved. But notice here, the shopping cart in this case requires a customer to exist. So the shopping cart and customer have a relationship, and it doesn't make sense for me to have a shopping cart with a customer. Now this is a rule that's put out there. What it's saying is I am not going to allow anonymous people to shop, or I have to create a customer object that represents the anonymous person. There's a rule that's implied inside of that. So the class diagrams can tell us quite a bit about the rules of a program, and thus we'll use them to talk about the rules of data structures as we go through and build them later on. Probably just as often, maybe more often, we'll use object diagrams to describe data, code while it's running. That's what object diagrams are for, is runtime instances of things running. So objects are also boxes, only the objects underline the name. So instead of the class name being inside of here, I normally have some sort of object name, a customer lowercase c. Since it's named customer here, I don't necessarily have to tell you what class it is. I can assume it. But there is an option where I can say it's current : shopping cart, because current doesn't mean anything. When I use these boxes, I normally only have one compartment, which is the attributes and the value of the attributes, because the methods are the same across all object instances. I breathe the same as you breathe. Our hearts, they beat basically the same way. So that idea is those behaviors are common across the entire class, all the species, if you will, of objects. But the behaviors might, the values might change a little bit. And just as kind of an example here, you can actually show multiple of them. You can stack them. You can do all sorts of interesting creative things. So I have a bunch of payment methods. And so the objects themselves are reflections of the a real-time instance of a class. So in this case, I have a customer whose name's Tony, whose birthday is September 5th. He has 3 payment methods in this case, and the current shopping cart was just updated. Right now is when the shopping cart was updated. This is talking about a moment in time. Now, the relationships change a little bit in this. The associations turned into what's called links. There's links between objects. There's associations between classes. An association is a potential link. It describes the link. The link is the actual thing. There could be the shopping cart current might not link to Tony. It might link to a different one, or some of these payment methods might not be Tony's. There could be objects out there, and they could be Tony's payment methods if it gets assigned to be one. But I do that by establishing a link. And so they really look the same. I draw the line in between that. Notice in this case, I'm cheating a little bit. I'm not drawing a line to each one of the three. This UML is quite flexible in how I draw things. It's really the intent that's out there, but by sticking to the normal conveyances, not putting crazy arrowheads, not putting the wrong text in the wrong space, by sticking to the conventions, it portrays a lot of data, a lot of information. You'll get some practice on reading that data if you don't know about it already. But this is kind of a concept to get those things prepped for you. So remember, the class name is the top compartment. That middle compartment is going to be all of your attributes or the values of the attributes for object diagrams. And then if you have a third compartment, that's going to be your methods that is going to describe that. So really, the idea of this is to communicate your designs with style, to do it in a very professional, elegant approach. We can always write on whiteboards, write on napkins, share ideas, and often we can express those ideas. But by putting that into a formal language, I'm expressing that with much greater clarity. I use proper grammar and spelling and everything else when I communicate with other people, because then I kind of assume they know what those things mean. At least the number of misinterpretations is much lower at that point. And so this is one way you can do that in your software practice, is by using UML and learning UML, and using it to communicate your ideas. And we'll use it through this course as we talk about some of these complex data structures as well.